Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. Here you have information about this video channel, how you can find it. It's at smarturl.it/pass actuarial exams. And actually, I need to add that we also have that I also offer exam IFM manual, and I also offer exam LTAM manual. And you can find the study manuals that I write and the online seminars for exams P, FM, IFM, and LTAM at these websites. Just type in smarturl.it/btdt-online for the seminars and btdt-pfm, IFM, LTAM for the manuals for these exams. I direct the actuarial program at Illinois State University, which is a Center of Actuarial Excellence, a title granted by the Society of Actuaries, and a winner of the Casualty Actuarial Society University Award twice in 2016 and 2019. And Illinois State University is also a Global Center of Insurance Excellence. And you can find information about our actuarial program at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. Let z be a random variable with standard normal distribution. Find the expected value of z given that z is more than 0.45. And here's a solution. It actually may look tricky, but it's not that bad. So we write w equal to z given that z is more than 0.45. And let's write phi for the cumulative distribution function of the standard normal distribution, while phi of z equals, which equals 1 over square root of 2 pi times e to the minus 1/2 z squared, is the density of the standard normal distribution. Then f sub w of w is phi of w over 1 minus phi of 0.45, because that's the probability that z is more than 0.45, 1 minus phi of 0.45. And we can actually look up that value, 1 over, actually 1 minus phi of 0.45. So we can write this as 1 over 0.3264 times the square root of 1 over square root of 2 pi times e to the minus 1/2 w squared for w greater than 0.45 and 0 otherwise. Therefore, the expected value of w is this number, 1 over 1 minus phi of 0.45, which we actually figured out numerically already. But anyway, it's a number, times the integral from 0.45 to infinity of w times the density that, it's actually w times the density, but we pulled out a constant in front. So w times e to the minus 1/2 w squared over square root of 2 pi. And we do integration by parts by taking z to be 1/2 w squared, so that dz is w dw. I'm sorry, we're not doing integration by parts, of course, we're doing integration by substitution. So we substitute z equal to 1/2 w squared, dz is w dw, and when w is 0.45, z is equal to 0.10125, and when w goes to infinity, z goes to plus infinity. So we do this substitution. What do we end up with? We end up with 1 over 1 minus phi of 0.45 times square root of 2 pi. The constants times the integral from 0.10125 to infinity of e to the minus z dz. Oh, that's very nice. Notice that we have this w dw that was substituted by dz because of the way the substitution works. And, well, you know how to integrate the exponential function. So that's not that hard. The integral of e to the minus z is minus e to the z, minus e to the minus z. And we evaluate it from 0.10125 to plus infinity. Of course, at infinity it's 0. So it's only minus the value of that function at 0.10125, which is e to the minus 0.10125 over 1 minus phi of 0.45 times square root of 2 pi. We actually already looked up the value of 1 minus phi of 0.45, so you plug that in, multiply by square root of 2 pi, take the reciprocal of that, multiply it by the value of e to the minus 0.10125, and we get approximately 1.1047, which is answer D. Please remember this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.